Hello everyone, this is your NJ and you are watching GetWays solution. In this video, again I will solve a LeetCode question. So without any further delay, let's get started. So the question goes like this: design a stack that support push, pop, top, and retrieving the minimum element in constant time. So here the thing to stress on is the constant time. So here we have given a constructor minimum stack and a method push and pop and top and one get minimum method. So as we know, like push method in stack already take O of one time complexity, and pop also O of one and top also O of one. We generally have to do a get mean method in O of one time. So task is that get the mean method in O of one time. But how we'll do that? What is the straightforward solution? Like most brute force solution when we think of this is like coming in my mind is that like okay, let's do the stack, let's push the element in stack and pop the element in stack as we do generally. And when we call the get mean method, at that time just iterate through the stack and get the minimum method and get the minimum value and return it. Just iterate through the stack, get the minimum value and return it. That's the solution. But just think of that it is taking O of n time. So let's do it and let's see that are we getting time limit exceed on this solution or not. So okay, I will declare a stack of integer stack, and I will initialize the declaration new stack. And in push method, simple, I will do the push operation, push that. And in pop, again I will do the normal pop operation. And in top, I will return pick the top element. To get the top element, we have method pick in stack. So now to get the minimum element, what we will do? I will declare one mean variable, and in that I will by default I will pass a maximum value, so that when we see the first element of stack, then only we'll update. That's why we pass the maximum value, integer dot max value. Or you can pass some greater integer, but you don't know like what's the range of the stack. So always good to have maximum value. So now I will iterate through the stack and using for each loop. So let's say element as e and stack is st, and I will iterate through it and I'll find the minimum value, update the minimum value using math.min function. You can use if else also to do that, but if you have something neat and clean, why to create a mesh? So we'll take minimum of mean or e, and then we will return mean. That's it. And now I'll try to submit it, and hopefully, probably, we will get time limit exceed. So I'll try to submit. Oh, it got accepted, but this should not be this should not happen, because our question asked us to implement in O of one time, but we have implemented in O of n time. Still, it got accepted. But I will discuss the optimized solution. Though it got accepted, so we have to know like the optimized solution. If this kind of question came in interview, we have to give the optimized solution. Whatever interviewer asked us to give O of one solution, we have to give O of one. We don't have to give O of n. So now let's jump into the minimum. How we'll find the minimum? Let's build the intuition. Suppose we have a stack and we already know, okay, while pushing on a stack O of one, while popping on a stack we have O of one, while getting top from the stack we have O of one. So how we'll get minimum? How we'll get minimum in O of one? Suppose we have some stack, we have some data structure or something like, let's say stack, we are discussing about stack only. So suppose we have a stack which has top value always minimum, always minimum. So in that case, in O of one time we'll get. So let's say, let's visualize in a diagram. So here we have stack, normal stack, and here we have minimum stack. So suppose we got a value as push one to the stack. Okay, so with this statement, what we'll do, we'll push one to the normal stack, the original stack which we have. And since this is the first element, right now stack is empty, so we're gonna push in minimum also one. So we have only one element, and right now minimum is one only. So now suppose you got another element, push 2. This statement, when you encounter this, so at that time you will push 2 to this stack. But while pushing to minimum stack, we will compare is 2 is lesser than the top of minimum stack, which is 1, is 2 lesser than top of the minimum stack? No, this is not the case. So in that case, what we gonna do, we will insert the top of the minimum stack again. Instead of pushing 2, we'll again push 1. Got it? Now again, suppose we got push 3, so we'll push here. Again we'll ask, is 3 lesser than 1? No, it is not. So our minimum value is 1. So now suppose we got a value push -2. So we'll push -2 here. And is -2 lesser than 1? Yes, indeed, of course. So we will push -2. So whenever someone asks at any stage, suppose we are popping, we have suppose someone asks now, like, what is the minimum? We will say that top of minimum. Okay. So right now minimum is -2. So if someone asks what is the minimum, we will say -2. And now suppose now after getting the minimum method, running the minimum method, someone run pop method. So this got pop, this got pop. Okay, both of them will pop, both of them. Now at this point of time, when someone asks out of 3 2 1 what is the minimum, we'll say 1, of course 1, of course 1. So again this guy got popped and this one also get popped. Someone ran the pop method, both of them got popped. We call pop method, both of them got popped. Now someone asks what is the minimum in 2 and 1, we will return the top. 1 is the minimum. So this is how using two stack we can implement, we can get the minimum in O of one time. We are just returning the top element, and that happened in O of one time. So how what will be the pseudocode, what will be the algorithm? I will tell you if you are wondering, and yeah, it's fine, we got it, like we have to do two stack. But how? It's really simple. Like we don't have to do any change in pop method, top method, and in min method we'll just return the minimum stack top. And we have to do certain changes in push method. In push method, what we will do, we will push in our normal stack st.push the value. Suppose in push we have v, so we will just push the value. And while pushing to the minimum stack, we will do a check. First we will do one check, is that if this stack is empty. If it is empty, then we have to put this same value. Since it is empty, and if it is empty, it means that this is the first value. So if it is the first value, means it is the minimum value. So first we will check if it is empty, and if it is empty, we will just push the value. So min stack and push. So push the value. I'm writing like a doctor, but yeah, I will write code again, so everything will be clear. So if it is not the case, if it is not empty, in that case else, what we will do, we will return, we will push minimum of top of this and the value, minimum of value and top. So I'm just whatever I say that you listen, that I'm writing, it's so it's a little bit complicated. So let's jump into the question and do it. It's easy. So I will write the code. We have already declared the normal stack, so I will just override this code. Integer, it's not override, it's override. So it's minimum stack, so I will call minimum stack as min s. So I'll initialize minimum stack also, min s equal to new stack. Voila. So we have declared and initialized both the stack. Now while pushing, we have, for normal stack we will do nothing, and for minimum stack we will do the check if min s is empty. If it is empty, then in that case what we gonna do? In that case we will push min stack dot push. In that case we push the value. Okay, so else if it is not the case, then if stack has certain element, then we will compare the minimum element. So min stack dot push, and what we will push here, the minimum element. So how we will get the minimum element? Math dot mean of value and min stack dot peak. How we'll get the top element of minimum stack? Using peak. So hopefully you got it, everything is sorted. So this is push method. In pop method, what we'll do, min stack pop, we'll pop both the stacks when pop method will call, so that we have a trace of every stage. At stage 0 we have minimum 1, at stage 1 we have minimum 1, at stage 2 we have minimum 1, at stage 3 we have minimum -2. And when we pop the stage 3, we will come to stage 2. When we pop the stage 2, so we have to pop both the stack. That's the intuition here. So in order to get the top element means what is the element at the top. So it's not the minimum element, so we have to return the original stack dot pick. So we don't have to do anything. And while getting the minimum element, so we have to return the minimum stack dot pick. Hopefully everything is sorted, you got everything. Now I'll try to submit the code. Minimum stack dot is empty. Sorry, where's the code? Minimum stack dot is empty is a method. Now I'll submit. So it got accepted. Hopefully you understood it. Thank you. Bye bye.